Okay, so today's lesson's a lot quicker than yesterday's lesson, but yesterday what we had is we had these right here where we were multiplying, let's say, two binomials together. So it was just multiplying. You'll notice that today the difference is you actually have an equal sign as well. So whenever you have an equal sign, it means that we're going to end up solving. We're going to end up solving and getting an actual value for x. These can be pretty tricky. So what I'm going to do is I'm actually going to start from the bottom up. My first example, my number one, my first example is going to be this one right here, where we have a binomial times a binomial on this side, right? So you have a binomial times a binomial equals a binomial times a binomial. So I'm going to do this one first. You can use an area model, but today I'm going to kind of break away from that area model and talk about like distributing instead. So in this one, I'm going to multiply my x times my x to get x squared. Then I'm going to multiply my x also times my 7 to get plus 7x. Okay, I'm done with my x. Now I move over to my -1 and I multiply that times x to get negative x. And then I multiply my -1 times my 7 to get a -7. Okay, I'm going to put that is equal to, and now I'm going to do this side. I have x times x is again x squared. I have x times -3 is -3x. I have 1 times x is positive 1x. And last but not least, I have 1 times -3 is -3. Okay, I have some work to do on this side first, so I'm going to simplify this side. This side I get x squared plus, if I have 7x minus an x, I get 6x's, and then minus 7 equals. On this side, I have an x squared, and then these simplify. So -3x plus 1 is going to give me a -2x. And then I have minus my 3. Okay. So since I have an equal sign, I'm going to start trying to combine like terms on certain sides. Like for example, I'm going to try to move my x's over here for me. Okay, so I'm going to subtract first of all my x squared from this side. When I do that, when I put a minus x squared over here, you guys will notice it actually goes away on both sides. So I'm left with 6x minus 7 on this side and -2x plus 3 on this side. What I want to do next is I'm going to add my 2x to this side to get rid of it over here. So I'm going to add my 2x over here. Okay, I'm going to go ahead and do that first before my next step. So I have 6x plus 2x is an 8x minus a 7 on this side is equal to -3 on this side. But I obviously want to make sure that I get my numbers on this side and my letters on this side. So I'm going to add the 7 to the other side, plus 7. Okay, I'm going to come up here to finish out that work. When I add 7 to this side, a -3 plus 7, I end up with 8x on this side and 4 over here. My last step is to actually divide by 8 here. And I get x is equal to 4 over 8. But that actually reduces, a 4 goes into both of those numbers. So I get 1/2 as my final answer. 1/2. X equals, sorry, you can't see that. X equals 1/2 is my final answer because 4 goes into 4 one time and goes into 8 two times. So that's how we would do a problem like that. You should end up with a solution anytime you have an equal sign. Okay, so I'm going to go to one of these other problems. These are pretty complicated, and let me show you why. This right here is the complicated part. So a lot of people want to do, well, what is 2x minus 5 times this? And they'll like start putting in parentheses. You don't put in parentheses. So for this one, what I have to do is I have to use that idea of distributing this -5 to both of these. So what I really have is like this 2x, but then this negative 5 gets distributed to the x, and it gets distributed to the 4. So I have 2x, and then negative 5 times x is minus 5x. And then negative 5 times 4 is negative 20. Because that negative 5 is really what's multiplied times it. On this side, this negative 2 has to get distributed to both of them. So I end up getting equals negative 2x, and then negative 2 times 3 is negative 6. Okay, so now I'm going to go through and solve this. So simplify like we did before, right? So here, if I have 2x minus 5x, that's a negative 3x on this side, minus 20 is equal to my negative 2x minus 6. So again, I'm going to kind of come up here to work this one out. I want to move my x's on this side, my numbers on that side. So I'm going to add my 2x right here, add my 2x. It goes away over here, and I end up with negative 1x, because a negative 3 plus 2 is a negative x. And then I have minus 20 is equal to negative 6. But I need to move that 20 to the other side, so I'm going to add 20. I'm going to add 20. 20 minus 6 is 14. So I have negative x is equal to 14. Well, I don't want a negative x. I want a positive x. So I really kind of like what I do here is I divide by a negative 1, or I make the other side negative. My answer is x should be a negative 14. X should be a negative 14. Okay, so this says let's check our solution. I didn't do this in the first one because we ended with 1/2, but I do want to show you guys how to check your solution. On a quiz, you should never get this wrong because you should be checking it in your calculator to see if you get the right answer. If you do, then it's going to work out. If you don't, then you've done something incorrectly. So what we're going to do is I'm going to plug it into my calculator for you. So what we have here, I should have 2 times negative 14 minus 5 times my negative 14 plus 4 should be equal to negative 2 times negative 14 plus 3. Okay, I'll do a little mental math first. This right here, negative 14 plus 4, that should give me a negative 10. And then I have a negative 5 times a negative 10. So I really have 2 times negative 14, which should be a negative 28. And then I have negative 5 times a negative 10. That should be a positive 50. And that should equal negative 14 plus 3 is going to be a negative 11. And then negative 11 times negative 2 should be a positive 22. Let's see if that really is the case. If I do 28, and if you guys flip it to the side, your phone like that, if I do 28, there's a little negative in it, negative, and then plus 50. Sure enough, I get 22. So you can see that means that 22 equals 22. I did it correctly. I did that one correctly. Okay. I'm going to do one more. So that was our second example. Our third example is actually right here. It's kind of buried or hidden right now. But that's our third example. I will not be doing this one. This one looks very, very similar to this one. Okay, in fact, is it the same one? It sure is. So we're not going to be doing that one, okay, with good reason. But this one will be our last one that we do. And this one's really tricky because it's kind of like when we had this negative 5, that was what was multiplied times both of them. But in this one, there's no number there. Well, I'm going to make an invisible number whenever that happens. It's really a negative 1. And that negative 1 is getting multiplied times both of them. That's really what's happening there. So in this one, I have a 4x, and then I have a negative 1 times 2x is going to be a negative 2x. And then a negative 1 times negative 5 is going to be a positive 5. And then that is going to equal 18. Well, that's kind of nice. I didn't have to do any math on that side. So now I'm going to go ahead and simplify this. I'm going to do 4x minus 2x. So I get 2x plus 5 is equal to 18. I'm going to subtract my 5 to the other side so that my numbers are over here, minus 5. And I end up with 2x is equal to 18 minus 5 is 13. And now I'm going to divide by 2, and I end up with x is equal to 13 halves. 13 halves, which you might see is 6.5 or 6.5. So when I check it and I plug it in, I might do that. Like I might put in 6.5 instead of 13 halves because it's a little bit easier to plug in. So what I'm going to do to plug it in, to check it, I want to check it with 6.5. I would have 4 in my calculator times 6.5 and then minus 2 times 6.5 minus 5, and that should be 18. Let's see what we get. 4 times 6.5, I get 26, and then minus, and now I'm going to do 2 times 6.5, which is 13, but I have to subtract 5, minus 5, I get minus 8. That should be 18. Well, sure enough, 26 minus 8 is 18, because 26 minus 6 would have been 20, but I have to take away 2 more. So there we go. I now know that is the right answer. Okay, so there's 3 examples of solving equations when you have these binomials. Go ahead and go to the practice and get started on finishing the rest of the problems that look similar to this. Good luck.